Welcome to our video demonstrating the portable veneer mill developed in a joint venture by Erickson Products and Lincoln Industrial Corporation of Port Angeles, Washington. The mill is designed to utilize small, short, and low-grade logs to produce 4-foot inter-ply veneers for plywood and laminated veneer lumber products. It is fully portable, requiring no infrastructure other than relatively flat, firm ground. Quality, recovery, and man-hour productivity are at or exceed industry standards. This particular mill is configured to run 5-inch to 16-inch diameter blocks that are 51 inches long. With a 2 or 3 person crew, it will process 20 to 40 tons of blocks per shift and produce 12 to 30 tons of marketable veneer. Blocks are accumulated in a jackladder and automatically indexed into a mechanical V centering system. They are then moved to the lathe spindles with an end-dogging pendulum. This centering function is very critical to optimizing recovery and quality. It is semi-automated, allowing the operator 2 visual checks and the ability to override and correct as needed. The veneer lathe utilizes a mechanical ball screw feed system, powered spindles, and a surface drive roll. It also has a 6-point floating head backup roll system. For ease of maintenance, off-the-shelf components are used as much as possible and moving parts are kept to a minimum. It is capable of the full range of standard thicknesses from 100 thousandths to 200 thousandths. In this demonstration, it is set to peel 126 thousandths. Blocks can be peeled with the bark on, as is being done in this video. However, debarked logs are an advantage as they bring less dirt and rocks, which shorten knife life considerably. Knife changes take about 10 minutes, with 1 or 2 per shift being normal for peeling logs with the bark on. Core size varies between 2 and 3 inches, depending on species and peel thickness. In our demo today, we are peeling red alder at 126 thousandths and dropping a core diameter of 2 3/8 inches. The veneer ribbon is peeled onto a conveyor belt behind the lathe and fed into the clipper. The clipper is manually triggered to cut out the oversized defects and bark at the start of the ribbon. Once into the solid ribbon, it is switched to automatically cut to the standard industry dimensions of 54 or 27 inches wide. Clipped veneer flows onto the green chain to be sorted and stacked by the off-bearer. It is sorted by width into bins. When average block diameter exceeds approximately 9 inches, 2 off-bearers become practical. Peeler cores can be manually separated from the trash flow to be utilized for firewood, chips, or other products. One good utilization we have found is to nail 2 together and use them as dunnage sticks for storing and shipping the veneer. The lathe is designed to hold full peel thickness to the very end of the ribbon. This eliminates the problem of thin veneer often associated with peeling lots of small diameter blocks. However, it leaves an edge on the peeler core surface that may interfere with any decorative use of the core. Veneer thickness is tightly controlled with a combination of ball screw feed, fixed nose bars, and the floating backup roll. In 4 years of full-time operation, our prototype mill had no customer complaints about this most critical of quality dimensions. Clip width falls well within industry standards due to our relatively low line speeds. Our low line speed and fixed nose bars also provide a surprisingly smooth peel, even on some species that are not commonly peeled cold. The surface drive component of the lathe leaves a track mark in the veneer. However, being 4 foot, it will be used only as interply, so the visual marks are not seen in the end product. Some have said they think this tenderizing effect actually helps the veneer lay flat as it is dried. Many species are suitable for peeling and produce marketable veneer. Growth characteristics may have some effect, and we would gladly answer specific questions regarding the opportunity in your area. Bark, scrap veneer, and unwanted peeler cores are accumulated and can be later ground for hog fuel or mulch. The mill needs no utilities and is powered totally by a 180 horsepower diesel engine. Functions are controlled hydraulically and pneumatically using 12-volt control power. When the mill is moved, tear down and set up each take about an hour. If you are looking for a way to get maximum utilization from short, small, or low-grade logs, this may be it. The portability and lack of sunk costs make this an appealing way to significantly get into an industry that is historically very capital intensive and lacks flexibility as log supply dynamics change. With its excellent recovery and small crewing needs, it has competitive efficiency and is more flexible by far than any other veneer option. We would gladly work with you to design in variations that would make the mill most suitable to your specific situation. We can be contacted